Okay, so hopefully you have these sheets called guided notes if you picked them up today for homework. If you didn't, you can just still use your own notebook. Our class today, welcome, is on evolution, our flipped class. And I'm on a timer here, hopefully in 9 minutes or less. We'll learn a little bit about evolution. So you probably have heard about Charles Darwin, and you probably did not know that this gentleman started out early in his life. He was 22 years old. He was actually interested in medicine, but was also a naturalist. And he went on voyages around the world, which really inspired him to think out of the box, so to speak, to look at organisms, make these observations, and all these observations really led to his theory, which today is the theory that we teach biology students because it's widely accepted, supported by much observation and hypothesis and testing of the hypotheses that he came up with. So his observation primarily started when he traveled around the world, but specifically in the Galapagos Islands, he started to look at giant tortoises. And if you look at your book on page 299, figure, right on page 296 actually, you can see the giant tortoises that we speak of and how he made observations on these islands where the tortoises look very similar on the islands of the Galapagos, but as he traveled to other islands further away, he noticed that they were also tortoises, but a little different, and even more different as he traveled to the mainland, which was South America. And these observations, not only did he make them with tortoises, he also looked at these birds, the rhea, the ostriches, and the emu, and started to ask himself why these birds look so similar, actually, but had differences as well, and were found in different continents. And your book does a very good job of illustrating these observations on page 299. So you'll see the rhea, which is located primarily in South America, the ostrich that he observed, the ostriches that he observed in Africa, and the emu, which he observed in Australia. And so even though these birds had similarities, they also had differences that really pertain to the habitat in which they were observed. Okay? And so he asked himself why that distribution, why were they in different areas all around the world, very far, and yet they looked similar as well. Okay? So these observations made him come to hypotheses and eventually theories that new organisms develop from pre-existing organisms over time. And that statement there, that's pretty much the powerful statement that really fills or completes our understanding of evolution. But there's much more behind that statement. Others had proposed similar theories to explain how evolution occurs. But why do we accept Darwin's theory today? The bottom line is the evidence. That's what science is about. So Darwin's theory was accepted because of his evidence, and his evidence mainly came from observations and testing of hypotheses. Now, during his time, the 18th century, the beliefs were totally drastically different from what he was proposing. So of course it was very controversial. Evolution is still controversial today. But what were the ideas back in the 1800s? Well, that organisms were permanent, that when they were here for eternity, and that they basically did not change. And the other idea was that Earth was a couple of years old, like thousands of years old, in contrast to what we believe today, that Earth is actually 4.5 billion years old approximately, and that organisms do change over time. And so what's some evidence? Because I said, Charles Darwin theory was really accepted because of his evidence. Well, scientists started to look at layers of the Earth, which we call strata. Strata is plural, stratum with the M is singular. And scientists came up with a law of superposition that basically said, as you look at rock, which if you look on page 298, figure 15-2, you'll see a nice picture of the Grand Canyon. And the Grand Canyon has been a place, and still is, a place where scientists, archaeologists study organisms, and they pretty much are able to look at the organisms that are in the bottom layers and realize that those organisms have been here for a long time, and some of them are actually become extinct. And as you go further up the strata, and you find other organisms, fossils, we can see that some of these organisms have changed, number one, by looking at these fossils, and you can actually see their age based on the age of the rock. And when we do that, that is called looking at, where are we? At the relative age. Okay? We have scientists such as George Cuvier that studied fossil bones, as I was mentioning now, that these fossils are found in different areas, and we can use the earth to really predict and estimate how all the organisms are. Okay? We also have more advanced mechanisms today with technology, but we'll talk about that later on. In addition, Charles Darwin read about Lyell's work, and Lyell was a very influential scientist in his time that was studying the earth and came up with his own theory of uniformitarianism. And in this theory, he basically said that earth has been changing through time, and the changes that really occurred in the past also continue to affect our earth today. And those changes are such as earthquakes that you may have studied in geophysics. Okay, and I said to you that there were other scientists that have tried to explain evolution. There's one scientist specifically that we want to bring to your attention is this Jean-Baptiste Lamarck. I'm probably going to have to stop for a minute here because after 9 minutes, you know, my video gets cut. So we're going to call this part 1. I'll stop this and start again in the next video.